Okay, so welcome back. We're still in chapter 4. We're looking at section 6 today. So we have been solving equations for a given variable. Sometimes the variable's on the right side or the left side or both, and this is true for an equation or an inequality. We're still going to be looking at those types of equations and solving those types of equations or situations that lead to those equations. But now we're going to look at, hey, we might not get an exact solution. We may end up with a situation in which our variable cancels out entirely, and we end up with no solutions or infinitely many solutions. And so we're going to take an answer and say, okay, does it have a solution, or does it have infinitely many solutions, or no solutions? And we'll look at this graphically as well and what that actually means graphically. But so what does it mean to have no solutions or infinitely many solutions? So when we solve a problem, we get something equals something. And we say, okay, is this always true or is it never true? If we get an always true situation, so if we solve an equation or an inequality and it's a true statement, then that statement is always true and has infinitely many solutions. It has infinitely many solutions if it's true. So there's any real number that would make that situation true. So what do I mean? When we solve that equation, we end up with something like 0 equals 0. Negative 3 equals negative 3. 81 is greater than or equal to 81. These are always true statements. 0 is always equal to 0. Negative 3 is always equal to negative 3. 81 is always greater than or equal to 81. They are true statements. We don't stop solving a problem. We solve it the whole way through, and we simplify it as much as we can, and we say, okay, well, does that make any sense? In this case, yes, it would be a true statement. So the solutions, then, we say, are all real numbers. So remember that symbol is real. So these are all real number solutions. So any number I pick to plug in for that variable, it will always make the equation still true. And you'll see what that looks like with the equations here in a minute. So next what we're going to look at, what if we have a situation that's never true? So let's say we solve an equation, we simplify it the whole way through, we solve it, everything cancels out again, but we end up with a false statement. So then that statement is never true and has no solution, so there are no real number solutions. So an example of this would be, we solve the equation, we end up with 5 equals 7. 5 will never equal 7, so that's not a true statement. 0 equals negative 8. Well, that's never true either. 0 is always 0. Negative 8 is always negative 8. If I say 5 is greater than 80, well, that's never true. 5 is never bigger than 80. So if we end up with this false statement, so a situation that's not true, we say there are no solutions or there are no real number solutions. So we can also just say, hey, no solutions. That would be our answer. Nothing will ever make that situation true. No matter what number I pick and plug it into that equation or that inequality, it will never make it true. So let's look at that algebraically with some actual example solving equations. Tomorrow in class we'll look at some word problems and we'll look at a little bit graphically of what this looks like on a graph or with a graph. So solve each equation for the given variable. So I'm going to go through this quickly because this is review. Simplify the left side. 7x, negative 3x, 4x minus 10. Distribute, we get 4x minus 8. Okay, so remember the goal is to get the variable to one side, numbers to the other. So let's say I just start with subtracting 4x from both sides. Negative 10 equals negative 8. So again, yes, 4x minus 4x is 0. That's 0. So what am I left with? Negative 10 equals negative 8. So notice I didn't just stop and say, I don't know what to do. There's no more x. I went ahead and finished out the problem and see what's left. So now I say, okay, well, negative 10 equals negative 8. Well, that's never true. That makes no sense. So since it's not true, it's a false statement, negative 10 does not equal negative 8, my answer then is no solutions. There will never be a number that I can plug into this equation that would make the left side equal the right side. All right, let's look at one more. So now we have an inequality. Remember, we solved these the exact same way. So the right side I can simplify. I get 7q minus 4, 60 minus 53. And the right side I don't need to do anything with. So now it's just a matter of get the variable to one side, number to the other. So I'll subtract 7q from both sides. Just one way to start, not the only way. This cancels and this cancels because I just get 0. So then I end up with 1 is greater than negative 4. well, there's no more variable, but so I finally asked myself, okay, well, is 1 always greater than negative 4? Yes, 1 is always bigger than negative 4. So what that means, because it's a true statement, I know my final answer is all real number solutions. So all real numbers, that's my final answer. So any number I want to pick and plug it in for Q. I want to plug in 5. Left side will always be greater than right side. I want to plug in negative 3. Left side will always be greater than right side. So no matter what number I pick to plug in for Q, the statement will always be true. So any number will work for this given situation. So I want you guys to solve a couple more problems and figure out what the solution is. So your homework tonight, solve each of these equations for the given variable, and then we'll discuss those solutions, what you got and why, and we will work more with this tomorrow in class.